So we're moving on to farming, and this is chapter 10 in your book. So, resources for agriculture. Agriculture has changed our environment by quite a bit. It takes up a large part of the area, the terrestrial area on Earth. So it's altering our patterns of vegetation. It alters soils and water resources worldwide because many types of agriculture are very water intensive, or sometimes we're trying to farm in areas where water is just not as readily available, so we're using up other water resources. Some agricultural lands have been depleted in just a few decades, while others can be sustained for centuries. So where we're doing agriculture is really important to what the impacts of it are. And the farming practices are also really important to determine what the environmental implications are as well. So some farming practices degrade agricultural resources, and some help to restore and rebuild those resources. So one of the big resources that farming uses is soils. And soils are complex ecosystems. A lot of people think of them as just dead dirt, but they're actually much more complex than that. Soil is a renewable resource that develops gradually through the weathering of rocks and the accumulation of organic material. The accumulation of topsoil, though, happens really, really slowly. Under the best circumstances, it's accumulating about 1 millimeter of topsoil a year. So it takes a really long time to build up a good layer of topsoil, but it can be lost really quickly. So if you manage it carefully and do practices that reduce erosion and make sure that we're kind of hitting near this best circumstances, you can grow the layer of your topsoil and at least retain the topsoil that's already there. Most farming techniques that we use right now, if we looked at the proportion of farms, we see that most of them are depleting soil, and this happens through erosion. So wind or water blowing or washing the soil away, and the removal of organic matter. In some places, there's very severe erosion, and it can exceed 25 millimeters of soil per year, which is about an inch. So let's go back. Best circumstances, you can accumulate 1 millimeter of soil per year. Worst circumstances, you lose 25 millimeters of soil per year. If you get it back to best circumstances, that means it's going to take at least 25 years to build up that amount of soil. Most places aren't doing this, so maybe it'll take 50 years or longer to rebuild that soil. So it's a really important resource that we can degrade really quickly if we're not careful. So we're going to spend a little bit of time talking about soil. For the environmental science majors in here, you will take other classes on soil, or it's possible some of you already have had those. There are 6 components of soil, and it has sand and gravel. So these are like larger bedrock particles. Silts and clays, which are very small mineral particles. Dead organic material, decaying plant material, basically. Soil, fauna, and flora, so this could be bacteria, fungi, invertebrates. There is water in soil, and there's also pockets of air. So variation in these 6 soil components produce many, many different kinds of soil types. For agriculture, one of the most important characteristics is soil texture, which relates to the relative amounts of sand, silt, and clay. So this graph shows some of the different soil classifications based on texture. So we have percent sand along this axis, percent clay along this axis, and percent silt along this axis. Loam soils are considered best for agriculture because they're a mix of all three components. So you can see loam is situated here, that has a high amount of silt, some clay, but not too much, and a medium amount of sand. And what do these different things do for you? So clay has the tiniest particles, so they pack together very, very closely. So water does not flow through the soil with clay. That's 100% clay very well. It's very compacted, and you get lots of like waterlogged soils if there's a lot of clay when it rains. Sand has really big particles, so water flows through it very quickly. And that's good if there's a lot of rain, but if there's very little rain, that means that the plants don't have very long to take water up. So if there is a lot of sand, then the water will just fall through. So silt has an intermediate particle size. So having a mix of all three of these retains water to some degree, but not so much that it's going to damage roots. And it keeps the water long enough that plants can soak it up. So that's the reason why loam soils are so important for agriculture. So in different areas, there are different kinds of soil. So this is a characteristic prairie soil. Grasslands put lots of nutrients in the soil. They put lots of roots in the soil, and that makes a lot of organic material build up in grassland soils over long periods of time. So you can see it's this dark color. It looks like it would be good for farming. And it has a good mixture of sand, silt, and clay that helps it hold on to moisture, but not too much. This is an example of a Brazilian tropical soil. A lot of people would think that like rainforests have a very nutrient-rich soils, but all the nutrients are already in organisms in rainforests. They're so biodiverse and they have so many plants and animals that every little bit of nutrient is taken up as fast as possible. So if you clear the plants away, what is left? You've already removed all the nutrients. There's not hardly any in the soil. So this is a Brazilian tropical soil that is clay. It's red. It has very little organic matter. It doesn't hold nutrients very well, and it's also acidic. So this diagram just illustrates us how complex soil ecosystems are. Oftentimes, this is an illustration of a forest. So we have a layer of leaf litter, and over time, this leaf litter is broken into smaller bits and incorporated into the soil a lot of times by earthworms and other types of organisms that do something called bioturbation. They're basically mixing the different layers by moving through them and eating different particles. But you can see there's lots of other types of organisms. There's soil fungus, there's nematodes and nematode-killing fungi. There are protozoans, all kinds of different things live in these soil ecosystems, and these help with nutrient cycling, and some of them also help the plants take up nutrients. So, soil fauna determine fertility. Soil bacteria, algae, and fungi decompose leaf litter. So, like in our forests when leaves fall to the ground, but in other places where dead plant material falls to the ground, this also happens. It's just really obvious in our deciduous forests because there's usually a very thick layer of dead leaves that come down in the fall and then slowly over the spring and summer get processed and incorporated into the soil. So there are tiny worms like nematodes that'll process organic material, and they create air spaces as they burrow. We have larger insects, spiders, and mites will loosen and aerate the soil too. And then there's also something called mycorrhizal symbiosis. We put symbiosis here because on different conditions, this can be beneficial or sometimes not beneficial to the plant, but under a lot of conditions, it's found to be a mutualism, meaning that both the fungus and the plant are benefiting from this association. But this is where the plant provides the fungus with carbohydrates, and the fungus helps the plant roots obtain water and nutrients, which can enhance the growth of the plant. So these are important fungi. They should not be confused with nitrogen fixing bacteria, which pull nitrogen out of the air and make it available. Mycorrhizae are doing something a little bit different. They're not getting nitrogen, they're not adding nitrogen to the soil. They're helping the plant get nutrients that are already in the soil out more easily.